How are we all doing? You're back with Jono for another quick math lesson. Today we're going to look at what happens to a term if its power is a negative number. It's a little bit unintuitive, it might not make sense to start off, but trust me, I'm sure you're going to find it pretty cruisy. We're going to start this by looking at a pattern recognition just so we can see what's happening. So in this table, I've got 2 to the power of 3, which is equal to 8. To change that into 2 to the power of 2, what I've got to do is get rid of the last times 2 from that expanded form, which becomes 4. So another way to think about it is that I'm dividing that term by 2. To turn 2 to the power of 2 into 2 to the power of 1, I again have to divide by 2, which leaves me with 2. And if you watch my last video, we know that 2 to the power of 0 is equal to 1, again following in that pattern. So what's happening here is that the power on top is getting reduced by 1, and the number at the bottom is being divided by the base. So if this holds up, this next answer from 2 to the power of 0 to 2 to the power of negative 1, instead of becoming a negative answer, all I've got to do is divide it by 2 again, which makes this 1 over 2, or a half. And then if I'm doing that again, dividing by 2, a half divided by 2 becomes a quarter. And this becomes an eighth. So a positive base will always give a positive answer. Even if the indice is negative, it just gets smaller and smaller and smaller and smaller, but it never crosses over to becoming a negative number. This is a super helpful relationship for us to solve these questions really quickly. If we have a look at up here, I saw that 2 to the power of 3 gave me positive 8 over here. If I had 2 to the power of negative 3 on the other side, that becomes 1 over that number I had to start off. So this is 1 over the same number. With this in mind, we can work these out incredibly quickly. So 5 to the power of 2 is equal to 25. So that means straight away 5 to the power of negative 2 becomes 1 over that answer. And that's all I've got to do. You can check that on your calculator to make sure it's right, but this is the rule every single time. So if we're going to write it out, the base and the negative power move underneath a fraction that has a 1 on top. The only thing that changes to the base and the power is that the power becomes positive during that switch. So here I've got x to the power of negative 5. So straight away, because it's a negative, I know I'm going to move it to the bottom of a fraction over 1. So I've got a 1 up the top there, divided by the exact same information, but with a positive power. So this becomes x to the power of 5. This next one with numbers, 7 to the power of minus 2 becomes 1 over 7 to the power of 2. 7 times 7 is 49, so my final answer is 1 over 49. One more example with an algebraic term, b to the power of negative 7 becomes 1 over B7. So you don't have to do a huge amount of work here. The powers are exactly the same as we've been dealing with. They're just on the bottom of a fraction. The only time we need to get a little bit cautious with proceeding with these questions is when there is a coefficient in front of the algebraic term. So this one I've got 3 multiplied by x to the minus 3. Just to do this, I'm going to write it out in a bit of an expanded form so we can see what we've got to do every time. So this is 3 multiplied by x to the minus 3. I'm just going to change that x to the minus 3 to the positive indices that we've just been doing. So this is 3 multiplied by 1 on x to the power of 3. While this looks like a good answer, we've got to get it in one fraction if possible. So the 3 multiplies with the numerator of the fraction, which becomes 3 over x to the power of 3. So if you write it out in this expanded form every time, I know you're going to get it right. But if you want to go to a shortcut, all you've got to do is the fraction, instead of being 1 over, is just the coefficient over the now positive indice. Thanks so much, guys, and I'll see you later.